Alrighty. This is Algebra 2, Lecture 921 and 922, OAS A2N12. The student will divide imaginary and complex numbers using the complex conjugate of the denominator. That sounds really hard, but it's simple. I'll show you what all that means, and hopefully it'll make sense and you won't have any problem with it. Here we go. First thing I want to do is talk about the complex conjugate. The instructions say find the complex conjugate of each. To find the complex conjugate of a complex number, remember that a complex number is just real plus imaginary. Real plus imaginary. And the imaginary can be negative. Real plus imaginary. Here in this case, it would be like plus minus 3i. We don't write plus minus 3i, but you could. So forth and so on. These are all imaginary or complex numbers. And I'm going to show you how to find the complex conjugate. It's the simplest thing in the world. All you do is you take the symbol that's in between these two and change it. Here's the complex conjugate. Done. Here's the complex conjugate. You don't change this one. Change this one only. Here's the complex conjugate. Done. Yay. I'm going to find the complex conjugate of this one. Just change the sign in between them. That's the only sign you change. Okay? Complex conjugate of 2 minus 3i is 2 plus 3i. Okay, so if you have complex numbers, any complex numbers, if you change the sign in between the two complex numbers, you have what's called the complex conjugate. And we'll be using that to divide here in just a second. Now sometimes you'll be given a pure, what we call a pure imaginary number, and you'll be asked to find the complex conjugate. So what you need to do is just think of it like this. You don't have to write this part, but you can imagine it as 0 plus 3i, because that's not a negative 3i, it's a positive, so we say 0 plus 3i. You can think of it this way. And then here's our complex number, real plus imaginary, and we change the sign in between it, 0 minus 3i. And generally, we don't write 0 minus 3i, we would just call it negative 3i. So effectively, all you're doing is changing the sign. So by the same token here, we can think of this as 0 minus 3i, the original. And if I wanted to find the complex conjugate, I would just change the sign. And again, we don't usually write 0 plus 3i, we just write 3i, and the plus sign is implied. So we just change the sign again. If you're given an imaginary number, a pure imaginary number, and you want to find the complex conjugate, just change the sign. Just change the sign. Okay? So that's complex conjugates. That's how we find them. Now here's how we use them in dividing complex numbers. To divide complex or imaginary numbers, pure imaginary or complex, all you do is you multiply the numerator and the denominator by the complex conjugate of the denominator. Multiply the top and bottom of this by the complex conjugate of the denominator. Okay, so here's what we're going to do. I'm going to multiply negative 6i by the top and bottom of this, because the complex conjugate of 6i is negative 6i, and if I multiply the top and bottom of a fraction by the same thing, I'm actually multiplying this fraction by this fancy form of 1. Okay? And so I'm not changing its value. We've multiplied complex numbers before, so I'm just going to go ahead and multiply the top by distributing. And that will give me positive 24i minus 36i squared. And remember, I squared, that's actually negative 1. Remember that? Little flare here. So this is negative 36 times negative 1, and when I rewrite that, I'm going to call that positive 36. And this is 6i times negative 6i. This is negative 36 I squared. 6 times 6 is 36. Negative times positive is negative. I times I is I squared. And this is going to turn into negative 1 also. So I'm going to rewrite this with these two negative 1's being multiplied by the number that's right next to them. I squared is negative 1. I squared is negative 1. I'm going to rewrite this. This will be 24i. I squared is negative 1. This is negative 1 times negative 36. This will be negative 36 times negative 1 is positive 36. And in the bottom, we'll have negative 36 times negative 1. That's positive 36 also. Okie dokie. Now what I'm going to do, now that I've got no imaginary numbers in the denominator, the reason we multiply the top and bottom of the fraction by the complex conjugate is because we don't want imaginary numbers in the denominator of our ratio. And this little trick, multiplying by the complex conjugate, top and bottom, will turn our denominator into a real number, which is what we want. And then once we get that, we've got to do a little bit of fraction magic, which is to say, I want to write this as two separate fractions and then reduce the fractions. So I'm going to call this 24i over 36 plus 36 over 36. And I'm going to reduce this. Now, these will both divide by 9. So I'm going to say, well, they won't divide by 9. They'll both divide by 6. I'm sorry. I'm going to divide both of these by 6. 24 divided by 6 is 4i. 36 divided by 6 is 6. Oh, they'll both divide by 12, won't they? Let's divide them both by 12. That would, I'm going to run out of room here. I'm an old brain damaged man. Sorry about that. 12 will go into both of these evenly. I would have seen that if I wasn't so old. Divide them both by 12. That will give me 2i over 36 divided by 12 is 3 plus 1. 36 divided by 36 is 1. Okay, and that's our simplification. This is 2/3 I plus 1. And that's in complex form. To put it in standard complex form, we can put the 1 first. 1 plus 2/3 I. You can put the I out to the side if you wanted to, or you can leave it in top. Just don't put it in the bottom. This is standard complex form, 1 plus imaginary, or real plus imaginary. Alrighty. So let's take a look at what we did. We said, hey, we have an imaginary number in the bottom. We don't want that, so we multiplied the top and bottom by the complex conjugate. When we did that, the bottom of the fraction, negative 36 times I squared, which is negative 1, turns into a real number. So now, all I have to do is a little bit of fraction work to simplify this. I said, hey, I can break this into two fractions. So I did. And then I reduced both fractions. And I didn't see that both of those would divide by 12 right off the bat because I'm an old man and it's about 6:30 in the morning. So these will both divide by 12, so I reduced that. These will both divide by 36. Anything divided by itself is 1. So I called that 1. And then I switched sides just to put it in complex form, complex standard, or standard complex form. Real plus imaginary. Let's take a look at another one. I'm going to multiply again to get I out of the denominator. We don't want that there. I'm going to multiply the top and bottom of this fraction by the conjugate of the denominator, the complex conjugate of the denominator. So I'm going to multiply, I'm going to change that sign, just like we did up here. Just change the sign. If you just have a pure complex or pure imaginary number, you just change the sign, that gives you the complex conjugate. So I'm going to multiply top and bottom of this by a fancy form of 1, which is 9i over 9i. This won't change its value, but it will change the way it looks. The top is now 27i, and the bottom is now negative 81i squared. I squared, again, got to remember, there's a little flare going off here. I squared is negative 1, so I have negative 81 times negative 1 is positive 81. Positive 81. And both of these will divide by 9. 27 divided by 9 is 3. I'm just reducing this fraction now. 81 divided by 9 is 9. Yes. Both of these will actually divide by 27. I can divide these by 3 again. So this will give me 1/3 I, 1I over 3, or we would call that 1/3 I if you wanted to stick it out to the side. So that will give me a pure imaginary number. Having trouble reducing my fractions in one fell swoop today. And I'm getting it done, but not dividing by the greatest common factor. So let's see what I did here. I said, hey, I'm going to multiply the top and bottom by the complex conjugate. That gives me 27I over negative 81I squared. This is negative 1, so negative 1 times negative 81 is positive 81. These will actually both divide by 27. I divided by 9 at first, but 27 divided by 27 is 1. 81 divided by 27 is 3. What I did was I divided by 9 and said, hey, those still have a 3 in them. So I divided by 3 again and got 1. And I just stuck the 1 out to the side. You can leave it in the top, but I like to stick it out to the side because that's how I've always done it. All right. So there we go. That's 2 examples of finding, dividing complex and imaginary numbers by multiplying the numerator and the denominator by the complex conjugate of the denominator. All right, here we're going to do the same thing. We're going to find the complex conjugate of the denominator. Just change the sign in between. Multiply the top and bottom by the complex conjugate of the denominator, and then simplify if we can. In the top, I'm just going to distribute. That'll give me negative 15 minus 15I. In the bottom of the fraction, I'm going to have to FOIL. I'm going to take this negative 5, and I'm going to distribute it, and then take the positive 5I and distribute that. Okay. And actually, this is a difference of 2 squares. We'll get into that in more detail later. Right now, we're just going to go ahead and FOIL. Negative 5 times negative 5 is positive 25. Negative 5 times negative 5I is positive 25I. And now I'm going to distribute this number, this value, to both of these using FOIL. F-O-I-L is how some people remember it. Negative 5 times negative 5I times negative 5 is negative 25I. And 5I times negative 5I is negative 25I squared. Now if you look at this real carefully, when I go to combine my like terms, I got to remember that this is going to turn into a negative 1, I squared. So this is negative 25 times negative 1. This will turn into positive 25. Let's look at these 2 terms. They're going to be exact opposites, which means they're going to turn into 0. 25I minus 25I is 0. So what I wind up with in the top of this fraction, I wind up with negative 15 minus 15I. Excuse me. And in the bottom, I wind up with negative 25 minus, because this is just a fancy 0 here, 25I minus 25I, minus 25 times negative 1. Well, that's plus 25. So I've got 25 plus 25, that's 50. Now I'm going to break it into 2 fractions and reduce. And hopefully I'll be able to reduce it in 1 step, but I might have to do 2 because that's what I've been doing this morning. Okay, so I'm going to call this negative 15 over 50 minus 15I over 50. And I see that both of these will divide by 5. So I'm going to divide top and bottom by 5. And that will give me negative 3/10 minus 3I over 10. And as I said earlier, I like to put my I out to the side of the fraction. Don't put it in the bottom, but just out to the side. Negative 3/10 minus 3/10 I, providing I haven't made a mistake. And I hope I haven't. It's early in the morning, and I've only had one cup of coffee. Hopefully I have not made a mistake there. But again, what we're doing is we're given a division of two values, one of which is a complex number, and it's in the denominator. To deal with that, we multiply the top and bottom by the conjugate, the complex conjugate of the denominator. Now we just have to do the multiplication, try not to make any mistakes, and when we get done, the bottom of the fraction, the denominator, should not have any imaginary numbers in it. That's what we're shooting for. That's why we're multiplying the top and bottom by the complex conjugate. And once we get that, we break it into two fractions, negative 15 over 50 minus 15i over 50, and reduce the fractions. And now we're in complex form, standard complex form. A plus bi. A is negative 3/10, b is negative 3/10. Okay. We'll do one more and see if it starts to make a little bit more sense. Here we go. I'm looking at this, and I want to write it so that I have no i's in the denominator, no imaginary numbers or complex numbers in the denominator. So I'm going to multiply the top and bottom of this, the numerator and the denominator, by the complex conjugate of the denominator. And that is just this when I change that sign. It's the complex conjugate. So that's what I'm going to do. Multiply top and bottom by negative 5 minus 3i. And when I get done, if I haven't made any mistakes, I will have no imaginary or complex numbers in the denominator. That's what I'm shooting for. Now in the top here, I'm going to have to FOIL. I'm going to take this negative 3 and distribute it. And then I'll take 2i and distribute it. F-O-I-L, you can think of it if you want to. So here we go. Negative 3 times negative 5 is 15. Negative 3 times negative 3i is plus 9i. And then I'm going to take the 2i and distribute it. It's positive. So I've got 2i times negative 5 is negative 10i. And 2i times negative 3i is negative 6i squared. And again, whenever we see I squared, that little flare goes off, because we've got to remember that that's a negative 1. So when I rewrite this, I'm going to consider this negative 6 times negative 1. I'm going to think of this as positive 6. Okay, that's a plus 6 right there. Negative 6 times negative 1. And in the bottom of the fraction, I'm going to scooch this over a little bit. I'm going to have to FOIL as well. So I'm going to take negative 5 times negative 5, and that will give me positive 25. Awfully big too. Then I'm going to take negative 5 times negative 3i. That's going to give me positive 15i. See if I can move that. There we go. And then I'm going to take 3i and distribute it. 3i times negative 5 is negative 15i. And 3i times negative 3i is negative 9i squared. And again, we have the flare going off, the same flare that went off here, goes off right here. I squared is negative 1. So I'm going to have negative 6 times negative 1, which is positive 6. Negative 9 times negative 1, that's positive 9 when I go to simplify. So now I'm going to simplify the top. 15, 9i minus 10i, that's negative 1i. So I've got 15. This is negative 6 times negative 1, that's plus 6. That's a plus 6 right there. 15 plus 6 is 21. 9i minus 10i is negative 1i, or you could just say minus I. You could put negative 1i if you wanted to. It's all right. Some people like to do that. I don't usually. but if you want to, it's not wrong. In the bottom, I'm looking here, I got 25 plus 59 minus 59. Look what happened. This is the exact same thing that happened last time. You'll see this a lot when we cover differences of squares. These middle two terms, when you multiply by the complex conjugate of the denominator, these middle two terms will always cancel each other out. They'll turn into a fancy form of 0, 25i minus 25i, 59 minus 59. And that's how we get rid of our imaginary numbers. That's what multiplying by the complex conjugate does. It leaves the denominator a real number, because this will happen every time when you multiply a complex number by its conjugate. So we got 25 plus 0 plus 9. This is negative 9 times negative 1. So 25 plus 9, I think that's 34, I hope. And I'm going to write that as two fractions, 21 over 34 minus 1 over 34, and you could call that 1i over 34, but I personally like to put my I